So in our last bit, we just looked at an experiment where we heated some copper carbonate. And can someone remind me what colour copper carbonate was?
Pale blue.
Pale blue, yeah, light blue. Good, excellent. So I'm just going to write that colour underneath it, just so we know. I know I've written it in red, but that's just to remind me it was light blue. What did I then do to that copper carbonate? What did I do to it? Heated it, great. This is why it's called thermal decomposition. So the way that I write that is on the arrow, I write heat. You'll notice there's no other reactant. I didn't put anything else in that tube to react with it. So there's nothing else in the boiling tube to react. So it starts with one thing. What did we notice happened to the, well, what happened in the reaction? What started coming out of the tube?
Vapor.
We know it's carbon dioxide. It was vapor because we could see the bubbles. Those bubbles made the lime water go milky, so very good inference made that it must have been carbon dioxide. So we know that it made carbon dioxide. It also, the blue stuff turned black. Now that black's on the inside of the tube, not the outside. Okay? So I know it's changed. And what did I say, or write that? So it turned to something black, a black solid. And it was a gas that turned lime water cloudy. Yeah? I'm just going to put lime water in brackets there, I'm not going to put the whole observation. Okay? So, as was correctly said just before, that gas must have been carbon dioxide. Okay, because it's the one that made lime water go cloudy. And I told you that it was copper oxide. Okay? Now I'm just going to quickly show you something. For when we work with carbonates and they make a gas, what we can see is happening. See the word carbon in there?
Yeah.
We move that up to here. And because it was a gas, we know which gas has got carbon in it, don't we? It's carbon dioxide. Alright? So if you see carbon on this side and it's heated, the better it makes carbon dioxide. You can almost guarantee that. Okay? So if you're heating something with the word carbon in it, put carbon dioxide on the right hand side. All good?
Yeah.
Okay. You'll also notice the word copper has stayed as a first name. So the only thing you need to remember there is what goes with it. What's the new word in our oxide? So you just need to remember the oxide word. Alright, you need to remember that that word goes with it. We're going to try another one really quickly without doing the experiment. This is one you're about to do the experiment for later. You're going to start with some calcium carbonate. Let's see if we can predict what would be made if I heat this.
Carbon dioxide.
Carbon dioxide. How do you know that?
You said the right. It's got carbon on the word.
Perfect. So I know I've got something plus.
Calcium oxide plus carbon dioxide.
Fantastic. So calcium.
God, shut up.
Guys. Calcium oxide plus carbon dioxide. Alright? Now it gets a little bit trickier when we do the one we did yesterday, which was with baking soda. Because that's got another word in it. And I'll show you why that's important. Sodium, hydrogen, carbonate. And this is one I would like you to learn off by heart. Okay? Because it's a different one. This one is a special one. So I'm going to put an asterisk next to it because it's one I want you to learn off by heart. Alright? Because it's a special one. When you have a hydrogen carbonate, things are a bit different. When I see the word hydrogen, that means that water is going to be made. Okay? If it's something hydrogen carbonate being heated, it's going to be water. Because it's got the word carbonate, it's also going to make what else?
Carbon dioxide.
Well done. So it's still going to have plus carbon dioxide, but because of the hydrogen, it's also got water. Because water, you might remember, is H2O.
And sodium oxide.
So it's got the hydrogens in it. Now this is the really hard thing. It doesn't make sodium oxide. Okay? That comes out to make the water. Some of that makes carbon dioxide, but actually you take the hydrogen out and that gives you the sodium thing. So it'll be sodium carbonate. So these two words go together. And sodium carbonate is washing soda. Remember what I said would happen if you use too much of this stuff? What would it taste like?
Right?
It would taste rank, yep. So it would taste like your clothes, basically. So that's why, because it would make a lot of the sodium carbonate. For those that are really targeting excellence, I'll work with you on how to do a balanced equation for that, because it's quite tricky. For those that aren't targeting excellence, so just going to look for merit, just make sure you know how to write the formula for each of these things. Okay, and that's using those yellow cards that we used. All right. So, if it's just a carbonate, what two things are made?
Carbon dioxide.
Carbon dioxide and an
Oxide.
oxide. Cool. If it's a hydrogen carbonate, what three things are made? Water, carbon dioxide, and a...
Sodium carbonate.
Well, it might not be sodium, it might be a different first word.
Hydrogen.
So it's a carbonate. Okay, that'll be a carbonate. So carbonate, carbon dioxide, and water. All right, stop there.